Number 54. Using the complete subshell notation, 1s2, 2s2, 2p6, and so forth, predict the electron configurations of the following ions, and then they give me A through F. Okay, so we've already done 2 problems that do electron configurations with ions. I think they were number 46 and 45, so go back to those if you want the more in-depth questions. If you are on the playlist, all you got to do is just find those numbers on the playlist. It's that easy peasy. All right, so we've done plenty of questions with electron configurations so far. So just know that this is the 1s. This is the, or not even the 1s, that's just the s orbitals. This is the d orbitals. These are the p's. And these are the f's. And just know that the s's start with 1, so this would be 1s. The p's start with 2, so this would be 2p. I guess I'll just leave that up here for now. The d's start with 3, so this would be 3d. And then the f's start with 4, so that would be 4f. Now, how do we take electron configurations for charges? Basically, those are ions, right? Ions are just charged atoms, whether they're cations, which are positive, or if they're anions, which are negative. They still have a charge. So every time you have to find out for an ion, the first thing you're going to do is you're going to get the normal electron configuration. So you're going to pretend that there was no charge at all, and you're going to just get the electron configuration for the certain atom, and then you will adjust to whatever the charge is. So adjust charge. So for A, I'm going to pretend that nitrogen has no charge. So I'm just going to write the electron configuration for nitrogen. So you always start with number 1 because they don't want the shorthand version, and you have to go to nitrogen. So nitrogen's all the way over here, number 7. So nitrogen would be 1s2, then drop down to 2s2. Remember, you always follow the atomic number, which is the whole number. And then you go to 2p3. Okay. That would be nitrogen without the charge. Now you have to add or subtract depending on what the charge is telling you. For nitrogen, a -3 means that you're more negative. So it means that you actually gained 3 electrons. And that's super important, and that's going to come up a lot through this course. So get into the hang of it by seeing negatives as far as like a plus, a gain of something. So anytime that you see a negative charge, you always gain electrons. Anytime you see a positive, you lose electrons. So it's kind of like the reverse of what you would actually think. So in this case, I have to just add 3 electrons to my outermost shell. And in this case, I have a P, and just know that the max electrons for an S is 2 electrons. For a P, it's 6. For a D, it's 10. And for an F, it's 14. So since this is not at its limit, the 3, you can add 3 more. So instead of making it 2p3, it would literally turn into 2p. 3 plus 3 is 6. And that's it. You adjusted it. So that's the answer to A. Now let's try B. B is Ca2+. So first write it for just calcium, and calcium is over here. So we got to start at 1, get all the way to 20, and then adjust the charge. So 1s2, 2s2, 2p6. Now we're over here. So that's 3s2, 3p6. Now we're over here. I have to cross both boxes to get to calcium. So that's 4s2. Now, the positive 2, the plus 2, tells me that I lost 2 electrons. And you always take away from the highest shell. And the highest shell here is the 4s. The big numbers in the front are the shell numbers. So the biggest shell, the most farthest away from the nucleus, is the fourth shell. And here's 2 electrons, so bye-bye. So they just go bye-bye. It's as simple as that. And when that happens, you could literally erase this, because those are the 2 electrons that you would get rid of, and hence that is the answer for B. You see how easy it is when you just put it what it is and then just adjust it. That's all that it is. C, S minus. Now, if there's just a minus and they don't give you a number, it's assumed that it's a -1. So I'll just put that there. So now we're looking for sulfur. Sulfur is over here. So first write the electron configuration for sulfur and then just make your adjustments. Got to start with 1. So 1s2, 2s2, 2p6. We're down here now, so that's 3s2. Then we move over here, so that's 3p, 1, 2, 3, 4. So that's 3p4. Now we make the adjustments. What did it tell us? -1 tells me that I gain 1 electron. So I literally add 1 electron to the outermost shell. And in this case, the one that's unfilled is 3p, because remember, a p can have a max of 6 electrons, and this one has only 4. So literally 4 plus 1 would give me a 5. So all I have to do is just erase the 4, and it now turns into a 5. And that's the answer for C. Halfway there. D, CS2+. So cesium is right down here. So this one's going to be a long one. But still, go from top to bottom. Work your way with number 1, get to number 55. So 1s2, 2s2, 2p6, 3s2, 3p6. Now we're down here. So that's 4s2. Then you move into the Ds. So that would be 3d10. Now I'm just going to write it down here because I don't have enough room. So this would be 4p6. Now you're down over here. You're in the 5s. So that's 5s2, 4d10, 5p6. And then now you're over here. So that's, where are we at? We're at 6. So 6s2. Actually, 6s1, because we're at the first box, you can say. Now this one is saying that it's cesium plus 2. So that means that I have to lose 2 electrons, and you always lose it from the outermost shell. And the outermost shell here would be the 6s. But look at here, there's only 1 here. So I can only lose 1 electron here, because there's only 1. So where else am I going to get the other one? Then you jump back, and you start taking away from the excess over here. So I lost 1 from here, I need to lose 2. So this 6 would turn into a 5. And that would be the loss of 2 electrons. So if I can just erase all of this and leave it as a 5p5, that would be the answer. 5p5, and that's the answer for CS2+. Next, E, Cr2+. Chromium is right here. So, still got to go from number 1 all the way to number 24. So, 1s2, 2s2, 2p6, 3s2, 3p6. Now we're down over here. So, 4s2, 3d4. Now, there's an exception, and I'm going to put it over here. If you ever end at an S2D4, I don't care whether this is a 5 and a 4, or if this is a 4 and a 3, you will always rearrange this. I'll say this is the old, out with the old, and in with the new. It's just due to stability. And if we draw the orbital diagrams, you guys would be able to see it. I actually do this very similar problem in number 53. So go back and check that one out if you want to. But this will always rearrange to S1, D5. And that's something that you're going to have to memorize. So in this case, I'm going to erase the 2 and 4 and put a 1 and a 5. And now I look at my charge. So now it's a +2, which means that I lose 2 electrons. Now, where is the highest number? This one is tricky because the highest number is actually in the middle, the 4. So I have to lose 1 from here, but I have to lose a total of 2. So where am I going to go? Now I look at the outer ones. This one had a 5, so I still need to lose 1 more. So this would turn into a 4. So technically this whole thing goes bye-bye, and now it's just a 3d4, and that's what you would write down. So I get rid of the 4s, and now I'm left with 3d4. Box that answer off, that's the E answer. And now I have to find GD, F. So I don't have any room over there, so I'm going to just put F over here. GD3 plus, this is an F. Okay, and now let's see, where is GD? One will never know. Can you guys find it? Ah, I found it. It's right here. Okay, so here we go. Gotta always start from the beginning and end at number, in this case, 64. So this one's crazy. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. I'm now dropping down to here in the 5, so that's 5s2, 4d10, and then I'm just going to go down a little bit because I don't have any room. Where am I? Okay, 5s2, 4d10, so that's 5p6. And now I'm at the 6 range. So I'm at 6s2, but then look here. Remember, whenever you hit this box right here, it drops you down into the Fs. So that's like a little, hidden gem. So whenever you're at 57, you go drop down to the Fs. So now I'm over here. So now I'm 4F. And then 1, 2, 3, 4, 5, 6, 7, 8. So that's a 4F8. And now I just need to find out what the charge is here. So we have a +3. So we got to find the outer one. The outer one is going to be 6s2. But there's only 2 there, right? So you can only get rid of 2 electrons here. With this, you needed to lose 3 electrons. And here, you could only lose 2 electrons. And then you would lose it from back to front. So you would go from 4F8, because that's your valence electron. So I need to lose 1 more, because I lost 2 already. So this would be down to 7. So if I can just clear this up, we get completely rid of the 6s2. Goodbye to that. And then the 4f now just turns into 4f7. 4f7. Box that answer off. That's the answer for F. And we've done all of them. What did you think, guys? Hopefully this helped. Let me know in the comments if it did. Love to hear from you guys. If you guys can do this, you are set for your test or quiz or, anything coming your way for Electron configuration. Awesome job, guys. Keep up the hard work. You guys been studying so hard. I'm so proud of you. Keep up the good work. All right. I'll see you guys all in number 55. And if you want to help the channel out, click the subscribe button. You'll get tons of our questions coming into your feed. And we post daily. So that's pretty cool. All right. See you guys later. Have an awesome day.